Question number, we are here about for 17. Find the equation of the plane which contains the line, again the question of line of intersection of the planes r dot I plus 2j plus 3k minus 4 equal to 0, and the other plane is r dot 2I plus j and minus k plus 5 equal to 0. Okay, and perpendicular. Okay, so one plane is passing through the intersection of these two planes and is perpendicular to, this is 1, this is 2, and perpendicular to the planes your r dot 5I plus 3j minus 6k plus 8 is equal to 0. Okay, so this is your plane number 3. Okay, so let us see, you know always that whenever the perpendicular condition is there, there is always a connection between the sum of product of direction ratios that turns out to be 0, which help me in finding the equation. Okay, so let us change to the Cartesian form first. So changing to Cartesian form. Okay, the plane 1 will be x plus 2y plus 3z minus 4 equal to 0, and second is 2x plus y minus z plus 5 equal to 0. So firstly I have to take the equation of plane through intersection of your 1 and 2. That is your first plane plus lambda times the other plane. That is 1 plus 2 lambda into x plus 2 plus lambda into y plus 3 minus lambda times z plus minus 4 plus 5 lambda equal to 0. So let's check its direction ratios, as the connection will be between the this plane is perpendicular to plane number 3. So this is 2 plus lambda and it is 3 minus lambda. Okay, and direction ratios of, check for the direction ratios of plane 3. They are, you can very clearly see 5, 3 and minus 6. Okay, so as plane number 1 is perpendicular to plane number 3. Okay, plane number A. Okay, I'm talking about plane number A, not 3. So plane number A is your perpendicular to this. So A1 into A2, this is A1 B1 C1, this is A2 B2 C2. So we will get it as 5 into 1 plus 2 lambda, 3 into 2 plus lambda, minus 6 into 3 minus lambda equal to 0. This thing implies it is your 5 plus 10 lambda, 6 plus 3 lambda minus 18, okay, plus 6 lambda is equal to 0. This thing implies 10 lambda, 13 lambda, and this is your minus 7 lambda, 5 plus 6, 11, 11 minus this is, I think again it is minus 7. So I think that lambda is going to be minus 1. Okay, so when lambda is going to be minus 1, you can check it whether it is minus 1 or not. Let me check it once again, because if it is wrong then the question is going to be wrong. So why 5 into 1 plus 2 lambda, 3 into 2 plus lambda, minus 6 into 3 minus lambda equal to 0. So it is 5 plus 10 lambda, 6 plus 3 lambda, minus 18 plus 6 lambda. So this is 5, 6, 11, and 11 minus 18 is this. Okay, okay, all the lambdas are in plus sign, sorry. It is 10, 13 and this is 19. Okay, so this always suggested that you should check it first. Okay, so lambda is going to be 7 by, it is plus 7 by 19. Okay, so this is 7 by 19. Okay, so let's put back here, we'll put it here in equation number B. So B implies x plus 2y plus 3z minus 4 plus 7 upon 19, 2x plus y minus z plus 5 equal to 0. Okay, so now you can I think in one go complete the equation. So it is 19x and this is 14x. Okay, so 19x plus 14x will be 33x plus this is 38y plus 7y. So this is 45y minus plus this 19 into 3, okay, and here it is minus 7. So it is your 50z, okay, and this is your minus 19 fours and plus 7 fives are 25. So you will get here as minus 41 equal to 0, which is the desired equation. Question number 18 says that find the distance of the point minus 1, minus 5, minus 10 from the point of intersection. Point of intersection of, there is a line and there is a plane. So suppose there is a plane, okay, whose equation I'm given as r dot I minus j plus k is equal to 5. In Cartesian form it can be written here as x minus y plus z is equal to 5. Okay, so a line is intersecting it. A line is intersecting it. Suppose this is the line, and its equation is also given as, your equation of line is r is equal to 2i minus j plus 2k plus lambda times 3i plus 4j plus 2k. Okay, in Cartesian form it can be written as x minus 2 upon 3, y plus 1 upon 4, z minus 2 upon 2. Okay, and let you know we can equate it to k, because I know that line and plane must be intersecting at a point. So I need that point. So let for some k, any point on line 2. Okay, the equation of line is x is equal to 3k plus 2, y is equal to 4k minus 1, and z is equal to 2k plus 2. Okay, so as line and plane are intersecting, so for some k, this point, this set of points, these points satisfies 1 because they are intersecting. Okay, so that means 3k plus 2x minus y, so minus y is minus 4k plus 1, and plus z, z is 2k plus 2, this is equal to 5. So 3 minus k is minus k plus 2, this is k, 2 plus 1 is 3, 3 plus 2 is 5, that is k is equal to 0 we get from here. Okay, so for sum that k, we are going to get this point now, which is q. So we get this set of points as the coordinates of point k are, as we will put k 0, so it is 2, this is minus 1, and this is 2. Okay, so I have to now find the distance of this point which is given here as this, from this point. Okay, so we can use distance formula. So using distance formula, distance between the point PQ, P and Q is given by x2 minus x1 का whole square, y2 minus y1 का whole square plus z2 minus z1 whole square. This is x2 minus x1 whole square, that is 2 plus 1 whole square minus 1 plus 5 whole square, 2 plus 10 whole square. Okay, so this is your 9 plus 4 square is 16, plus this is your 12 square is 144. So this is, you very well know that this is root 169, and the answer is 13 units. Question number 19. So question number 19 says find the vector equation of the line passing through, line equation of line I require. Okay, and parallel to the planes, r dot I minus j plus 2k is equal to 5, and r dot 3i plus j plus k is equal to 6. Okay, so this line which is passing through this and parallel to these two planes. Okay, let us check out the condition. So firstly, you know that equation of line passing through 1, 2, 3, and having say direction ratios I take as ABC. Okay, so equation in symmetric form is x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. So the passing through point is very clear to me. It is x minus 1 upon a, y minus 2 upon b is z minus 3 upon c. Okay. Now see, the line is parallel to the planes. See from here, these planes are there. You just look at the condition. Okay, if some line is parallel to both the planes, you can very well understand that if this line is parallel to these two planes are parallel themselves, and the normal to this plane and normal to this plane are perpendicular to this line also. Is this concept clear? That if line is parallel to two planes, okay, then definitely the plane's situation is like this. Okay, so normal to this plane and normal to this plane will be perpendicular to this line. Okay, so that means direction ratios of this line and the product of direction ratios of this plane or this plane will be your 0. So let us check out the direction ratios of a required line. Again, we will go for that condition which we had earlier in earlier question. And direction ratios of your plane 1, they are let's frame it as A, because again we have your line here as 1 2 plane already. Okay, so this is your 1 minus 1 2. Okay, and direction ratios of your plane number 2, they are 3 1 1. Okay, now according to question, the line is okay, the line is जो है that is perpendicular to the normals to plane. So direction ratios are something which are connected with the normals. So we will get the equation again, a minus b plus 2c equal to 0, and this is 3a minus b plus your c, 3a plus b, 3a plus b plus c equal to 0. Okay, so better here this question is not like the earlier we did. So let us check out how to apply that cross multiplication method here to get the values of a, b, c. Okay, so we can get it as a upon equal to b upon, you did it in class 10th, c upon. Okay, so 2 3 1 2 method is like 2 3 1 2, we go for this. 2 means the coefficients of the second term will be here. 3 is your 2 and 1, a is 1 and 3, and c here is minus 1 and 1. Okay, so let us frame here. This is minus 1 minus 2. Okay, so this is minus 3, and this is your upon this b, it will be 2 3s are 6 minus 1, that is 5, and here it is 1 plus 3, that is 4. Okay, so since direction ratios are proportional, so you can equate it to k also, but you can take, they will be proportional, so you can take the direction ratios a, b, c like this. So what will be your equation? Equation will be your a, x minus 1 upon minus 3, y minus 2 upon 5, z minus 3 upon 4. Okay, and you can change it to this your vector form like r dot. Okay, r dot, your passing through this point, line is passing through this point, so it will be your I plus 2j plus 3k. Okay, okay, this is r vector is equal to a plus lambda b. Okay, a plus lambda, and b here is your vector with direction ratio, so this is minus 3i plus 5j plus 4k, so which is the required equation of line. Question number 20. Question number 20 says that find the vector equation of the line which is passing through the point 1 2 minus 4. So I need vector equation of the line. Okay, and perpendicular to the two lines, perpendicular to two more lines, which are your x minus 8 upon 3 equal to y plus 19 upon minus 16, z minus 10 upon 7, and x minus 15 upon 3, y minus 29 upon 8, and z minus 5 upon minus 5. Okay, so we need vector equation of the line. So we can complete the question in Cartesian form and then frame the equation of line in vector form, right? So we know that your any line through the point 1 2 minus 4, and having direction ratios ABC. Okay, that can be written as x minus x1 upon a, so it is minus 1 upon a, y minus 2 upon b, and z plus 4 upon c. Okay, right? So this your line 1 is perpendicular to this line 2 and 3 both. So you know that the product of direction ratios is 0. So direction ratios of line 2 are 3 minus 16 7, and direction ratios of line 3 are 3 8 and minus 5. Okay, and the direction ratios of this required line are ABC. So we get it as 3a minus 16b plus 7c. 3a minus 16b plus 7c, this is equal to 0, and 3a plus 8b, okay, and minus 5c, this is equal to 0. So let us solve them by cross multiplication. A upon b upon c upon, right? We can apply the method of 2 3 1 2. So 2, under this we will take the coefficient of b, minus 16 8 7 minus 5 b, then it is 3 3 minus 16 8. Okay, so this is your 16 5, so 80 minus 56. This is your 21 plus 15. This is 24 plus 48. So this thing implies a upon 24, b upon 36, c upon 72. This implies we can take common things. Okay, so 12. So we can just make it proportional. So it will be 12 to the 24, 3 is a 36, and 6 a 72. Okay, so from here I can take the reduced form of direction ratios here as we earlier did. So direction ratios of a required line will be 2 3 6. So equation 1 changes to, this is your x minus 1 upon 2, y minus 2 upon 3, z plus 4 upon 6. Okay, so in vector form the equation is r dot I plus 2j minus 4k plus lambda times 2I plus 3j plus 6k, which is the required equation. Now question number 21 says, prove that if planes has the intercept. Okay, so plane has intercept ABC and at a distance of p units, from origin, then show that 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon p square. Okay, so you know that the equation of plane making intercept ABC with axis, this is x upon a plus y upon b plus z upon c is equal to 1. That is x upon a plus y upon b plus z upon c minus 1 equal to 0. Okay, now the distance p from the origin. So now perpendicular distance from origin to the plane, x upon a plus y upon b plus z upon c minus 1 equal to 0. We will use the formula for the perpendicular distance that we already know, ax1 plus by1 plus cz1 plus t upon under root a square plus b square plus c square. So this is point x1 y1 z1. Okay, so perpendicular distance here is p. Okay, so this is your 1 upon a into 0 plus 1 upon b into 0 plus 1 upon c into 0 minus 1 upon, this is your 1 upon a whole square plus 1 upon b whole square plus 1 upon c whole square. Okay, so this thing implies p here is minus 1 upon a square plus 1 upon b square plus 1 upon c square. Okay, so you can take the reciprocal of it, because outside this it will be like 1 upon under root 1 upon a square plus 1 upon b square plus 1 upon c square. Take the reciprocal, 1 upon p is your 1 upon a square plus 1 upon b square plus 1 upon c square, and squaring both sides we will get rid of this square root, and the equation will be 1 upon a square plus 1 upon b square plus 1 upon c square equal to 1 upon b square. Question number 22. Find the distance between two planes. Distance between the planes 2x plus 3y plus 4z is equal to 4, and 4x plus 6y plus 8z is equal to 12. Right? So see these two planes, you can find that both these planes are parallel planes. Look at the coefficients 2x, 4x, the direction ratios are proportional. So these planes are parallel. Okay, so you can see that planes are parallel here. Right? Now to find distance of a plane from any point x1, y1, z1 to, say, I'm taking to the plane 2. Okay, so the equation will be your a into x1. So this is 4x1 plus 6 into y1 plus 8 into z1, and this plane we need to take it as minus 12 equal to 0 as we go for the distance formula, upon 16 plus 36 plus 64. Okay, now see from here that this plane, distance of the plane from this point to this point. Okay, so this plane is lying on this one also, right? So x1, y1, z1 is lying on this plane 1, so it satisfies its equation. So 2x1 plus 3y1 plus 4z1 is equal to 4. Okay, so it is, this condition is like this, that say this is some plane, and there is a plane, you have to find its distance from this plane. So definitely this point is lying here. It may be this, we are talking about the perpendicular distance. Okay, so see from here, from these terms I can take 2 common, 2x1 plus 3y1 plus 4z1 minus 12 upon, this turns out to be your 16, 36 and 6, and this is 7, 1100, 16. Okay, now from this equation number 1 you can fill the values of this as 4. So it is 2 into 4 minus 12, and this becomes your 2 root 29. So this is 8 minus 12, so that is 4 upon 2 root 29, that is 2 upon root 29. So you will find that option number D is the correct answer. Question number 23. It says that the planes 2x minus y plus 4z equal to 5 and 5x minus 2.5 y plus 10z equal to 6. Are they perpendicular, parallel, intersect along y-axis, or passes through 0, 0, 5 by 4? So to check whether what kind of connection these planes are having, let us check out the direction ratios. So direction ratios of this first plane are 2 minus 1, 4. Okay, and the direction ratios of the second plane, they are 5 minus 2.5 and 10. Now check, is there any parallel condition which is lying? Yes, you can check. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Why? Because 2 upon 5 is equal to minus 1 upon minus 2 upon 5 and is equal to 4 upon 10. So you can check it as it is 5 by 2, so it is your 2 upon 5 is equal to 2 upon 5. So the planes are parallel. So option number B is the correct answer.